Hi everyone, this is Andrew Wolf. In this video I'm going to talk about alcoholic liver disease, but I also want to use alcoholic liver disease as a model to discuss the pathophysiology of cirrhosis. And cirrhosis, in this country, alcoholic liver disease is one of the most common causes of cirrhosis, but cirrhosis can also be caused by a disease called NASH, which is non-alcoholic steatohepatitis, which is caused by a disease process leading to fatty deposition in the liver, in the interstitial spaces of the liver. It can also be caused by viral diseases, hepatitis A, B, and C. It can be caused by hemochromatosis, which is a deposition of iron in the liver, and it can also be caused by a variety of toxins. And this list is by no means comprehensive. There are other things that can lead to cirrhosis, and they share many aspects of the pathophysiology in common. And the major thing that they share in common is that there is inflammation of the liver, and in particular inflammation in the space of Disse. Now, if you haven't watched my previous video about the physiology of the liver sinusoids, just to give you a reminder, the space of Disse is a space that it's otherwise known as the perisinusoidal space. Now, this space is in between the endothelial cells of the sinusoid and the hepatocytes themselves. So the inflammation in all of these diseases is occurring in the space of Disse. Now I want to begin our discussion of alcoholic liver disease, talk a little bit about how that inflammation starts. Okay, so the first way that alcohol leads to inflammation of the space of Disse is that alcohol, now I'm using the abbreviation ETO, which is an abbreviation for ethyl alcohol. Alcohol is actually a solvent to lipids, and it is a solvent in particular to the phospholipid membrane. Now typically we don't ingest enough alcohol to have a high enough concentration of alcohol to completely dissolve our phospholipid membranes. However, even a relatively small concentration of ethyl alcohol in our interstitial space can begin to loosen and disrupt the phospholipid membrane and make it act more like a liquid. And this has various effects on the cells. It can start to disrupt membranes, as membranes can actually as proteins in the membranes can actually sort of fall out of the membrane, and it also can just make them more liquid, so the membranes are moving around and they can't act the right way. But in any case, alcohol acting as a solvent to the phospholipid membrane disrupts the cells and cellular processes and leads directly to inflammation in the space of Disse because of its effects on the endothelial cells in the sinusoids and the hepatocytes directly. So that's number one, alcohol acting as a solvent to the phospholipid membrane, leading to inflammation. Now, number two has to do with the way that the body breaks down alcohol in the liver. And actually it breaks down alcohol in more places in the liver through the alcohol dehydrogenase system, or you can abbreviate it ADH, alcohol dehydrogenase. And this is actually a system of enzymes and coenzymes by which the body breaks down alcohol. Now, this process actually starts in the stomach. And interestingly enough, one of the reasons that men can drink more than women without feeling the effects of alcohol as readily is because men have a higher concentration of alcohol dehydrogenases in their stomach. But we also have this in our liver as well. And the way that alcohol dehydrogenase works is it works together with an enzyme, with a coenzyme. And the coenzyme is called nicotinamide adenine dinucleotide, and you don't need to know the name of it, but it's abbreviated NAD. Now, what happens when alcohol is being broken down? NAD is part of what's called a redox system, and I don't want to get too much into the biochemistry of this. So the NAD is actually helping to oxidize the alcohol and turn it into aldehyde. So NAD, when you add NAD in, the NAD changes to a form called NADH. And when this happens, the alcohol changes to aldehyde. Now, I'm just giving you background information. This is nothing that you need to memorize for the purposes of this class. But what I do want you to be aware of is that this NAD coenzyme is also very important for a lot of other things in the liver, one of which is gluconeogenesis. So when we ingest large amounts of alcohol, we end up actually suppressing gluconeogenesis, and this actually causes the liver to increase fatty acid production. So so that the body still has access to energy substrates, the liver increases fatty acid. Now, because if we drink large amounts of alcohol all the time, we are going to be chronically suppressing gluconeogenesis and chronically increasing fatty acid production. And what this does is it causes fatty depositions in the space of DC. I'm just going to say DC. And so you know what I mean here. So and this will lead, actually I'm skipping a step here. Okay, the fatty acid depositions actually cause inflammation by, number one, it activates Kupffer cells, and that's only one pathway. It actually has a number of other pathways in that it initiates the production of cytokines in the space of DC. Now, Kupffer cells, remember, these are the macrophages, so these are immunologic cells that are capable of initiating an inflammatory response. Kupffer cells themselves actually are stimulated by NADH, by high concentrations of NADH, to initiate inflammation via cytokines. Okay, so really the issue here is there's two effects of high levels of alcohol in the liver. One is alcohol working as a solvent, and then number two is the alcohol dehydrogenase system suppressing gluconeogenesis and thereby increasing fatty acid secretion, which directly starts a process of inflammation, and then also NADH stimulating Kupffer cells to increase the inflammation in the space of DC. Okay, and there's a third process in play here, And the third process would be that when we drink very large amounts of alcohol, we actually overwhelm our ADH system. We've used up every ADH enzyme and coenzyme that we have available. And so the liver needs to go to secondary pathways to break down. And these secondary pathways are using other oxidants that produce large amounts of free radicals. And these free radicals cause inflammation, and because there's so many free radicals, it causes the liver's trying to counteract these free radicals, so it actually causes depletion of antioxidants. Chief among them, the major antioxidant in the liver is glutathione. And I'd almost consider this a fourth one, depletion of antioxidants. And this is because the ADH is, we've drank so much alcohol that we're using every ADH enzyme that we have, and there's still alcohol in the liver, so the liver's responding to to the toxic levels of alcohol by going to secondary pathways of oxidizing the alcohol to break it down into aldehyde, and this causes very high concentrations of free radicals, and the free radicals cause inflammation to the cells of the liver because they directly damage proteins, they directly damage DNA, and all these free radicals also cause depletion of antioxidants, which can also increase the amount of inflammation in the liver. So those are the major ways that inflammation is caused in alcoholic liver disease. So once we have the inflammation occurring in the space of Disse, what happens is we have this peaceful little cell here. I haven't even talked about it yet. And this blue cell is a Kupffer cell, by the way. And we've already talked about how it is involved in the process of starting the process of inflammation. And this peaceful little purple cell here is a stellate cell. Usually it has a very boring, unimportant existence, although I think we are discovering that it's more important than we initially realized, but it certainly plays a central role in the pathogenesis of cirrhosis. Stellate cells usually live a boring life of storing vitamin A. But cytokines cause the stellate cells to be transformed from boring vitamin A storing cells to hyperactive fibrin depositing cells. And so we end up with fibrin deposition within the space of Disse. And actually, the stellate cells do even more than just depositing fibrin. They actually start depositing collagen, fibrin, and proteoglycans, which you will recognize as the components of dense connective tissue. So the stellate cells are stimulated to replace the entire fluid interstitial space of the space of Disse into fibrin scar. So this looks like scar tissue anywhere else in the body. Now this has a few effects. Number one, the hepatocytes are no longer have ready access to the nutrients coming from the sinusoids. So the hepatocytes will start to die off. And number two, the space of Disse actually gets bigger and thicker because it's filling up with this overgrowing, hyperactively growing scar. So what we end up doing is we end up moving the entire system here, and we end up having a much bigger space of Disse that's filled with scar. And what that does is it narrows the lumen of the sinusoid considerably. Okay, so let's write this all down in our sort of flow chart here. So we have inflammation, and the inflammation stimulates the stellate cells. And stellate cells begin to produce deposit fibrin and collagen into space of Disse. And that causes damage to the hepatocytes. And obviously you can see how this can actually start to cause a positive feedback loop, because what would a damaged hepatocyte do? Whenever you have cellular damage, you're going to cause more inflammation, right? So we're getting some positive feedback here, and we're getting to a downward spiral. Now the other thing is we have narrowing of the sinusoids. Now if you narrow enough sinusoids, what happens when you narrow the sinusoids? Well, remember Poisson's law. If we have a reduction in radius, what effects does that have? Well, it's going to have a significant increase on pressure, right? Because pressure is inversely related to the radius to the fourth power. So even relatively small decreases in radius can have significant increases in pressure. And where is the pressure getting increased? Well, that increase in pressure is getting transferred back to the portal vein. Now remember, the portal vein is a low pressure system. It goes from 10 millimeters of mercury down to 2 millimeters of mercury or so in the inferior vena cava. Now remember, the reason why it's so low here is because it's a vein that's already gone through a capillary bed. So if we increase pressures here, there really isn't a way for the body to compensate for increased pressure, so we just end up with backup into the capillary bed. And the capillary bed, remember, is in the gut, and so we end up with engorged veins and capillaries in the gut. And this leads to problems like esophageal and rectal varices, and it also interferes with gut absorption, and of course it leads to ascites. Okay, so again, we've got inflammation of the space of Disse that causes the stellate cells to deposit scar tissue in the space of Disse, and that narrows the sinusoids, causing portal hypertension, and it also causes hepatocyte damage. And actually, an alcoholic, a person that's been drinking for many years and has had slow, steady damage to the liver, can have very few functional hepatocytes. However, like all other organs in our body, we have a lot of extra capacity. So you don't really start to notice missing hepatocytes until you've decreased the number of hepatocytes by about 80%. And then when that happens, you begin to notice loss of synthetic function with derangements in coagulation, and you notice derangements in metabolic function, with hyperbilirubinemia and ammonia, etc. And then, I should also mention, and this probably isn't mentioned very often with the damage that's done to the space of Dissay, but the other cells that are very important that are damaged are the Kupffer cells. So this leaves the body open to enteric bacteremia, pneumonias, and really infections anywhere. This brings me to an end of my discussion of alcoholic liver disease and cirrhosis. Please take a moment to provide feedback, and if you have any questions, please leave them in the comments below, and I will endeavor to answer them. And I'm going to put up a couple links here, one to subscribe to my channel, and another one to as a quick link to the other gastrointestinal videos. So if you want quick and easy access to my videos, please click one of the links below. Thank you very much.